So here's the note on the Coriolis force. The Coriolis force becomes dominant to balance the pressure gradient force on timescales exceeding days. And what actually happens in that case is that the flows that you get actually tend to run along the frontal axis and not across. It's a very, very common feature for geophysical phenomena, like atmospheric fronts in the ocean. Okay, and this one is how a front looked like. A front is a zone where the density changes rapidly across the frontal zone. Okay, you have a density difference across this frontal zone. You have a frontal axis, and the geostrophic flow runs along the axis. Very strong winds in the atmosphere, strong currents in the ocean. All right. And the direction of that flow depends on the hemisphere. Depends on whether you're in the northern hemisphere or the southern hemisphere. Okay, the direction, no Coriolis force at the equator, but anyway. So the direction, whether it goes one way or the other way, depends on the geographical location. Okay, that's the note. So now another note is a very regional example, a popular example of density-driven flows is the outflow from Spencer Gulf. Every year during the winter month, okay, the density differences, okay, create a density-driven outflow from Spencer Gulf onto the ambient shelf. And this is one of the early observations which documented this outflow. Okay, this is from June 1986. So here's my laser pointer, and you can see lines here. These are contours, and the contours connect the same salinities. So these are the salinities, salt concentrations. Again, you can see numbers of 38, 37. Okay, this is hypersaline water. Okay, it's more saline compared to the ocean, to the ambient ocean. In the open ocean, salinities between 34 and 35, something like that, is way more typical. Again, you can see the outflow of saline water. This is near the bottom. Okay? And it's actually a combination of temperature and salinity that creates the density excess that drives the outflow. Okay, and I mention it at this point because this feature is very, very important to understand the renewal of water in estuaries like Spencer Gulf, because it's only the outflow that triggers the inflow of ambient water. There's new water coming in because there's water moving out. We call this flushing. Okay, this is the density-driven outflow from Spencer Gulf. All right, so just relax a little bit, have a break. We talk about the speed of these flows on the last slide of this tutorial. What's the speed of these flows? All right.